Hello everyone. This video is part of a series where we are exploring TypeScript's features with the help of a React application. Our main goal here is to learn how we can better type our code in order to improve confidence and velocity in development. In the previous video, we started discussing the idea of a class and how we can use classes in JavaScript. More generally, this is TypeScript, but in general, this would be the same shape of a class in JavaScript in order to represent or to provide a blueprint for a certain entity, for a certain object in the world. So if you're interested, check the previous video. I have a more detailed discussion about how to think a little bit in terms of classes and objects. In this video, I want to start exploring the concepts specific to TypeScript when it comes to classes. So the first one that I want to discuss with you are the modifiers. And these modifiers are little keywords that we can add in front of any field, or let's say any attribute or any method, including the constructor. I can also make the constructor private. We will see a very specific case when this is useful, but I can add these modifiers in front of every or any field in order to restrict the accessibility of those of those fields. Okay, so the first one is the private modifier, and the private modifier says that any field marked with the private keyword is going to be accessible only within that specific instance of the class, or within only that class. Okay, so let's come back here and let's mark our brand as private. Boom, brand is private, and boom, I have some errors, right? So immediately TypeScript is saying, okay, hold on, brand cannot be accessed outside the class microphone. Right, so I can only access the brand within the context of this class, but as soon as I'm outside of the context of this class, I cannot access the brand attribute. And I think I said in the previous video that we would work with another example rather than the microphone. So let's do that. Okay, why not, right? Let's think about another type of class. I could say electronic. Something like so, right? Electronic. And what would be an electronic? Well, the microphone is an electronic. Maybe we talk about inheritance using this example, but also my coffee machine is an electronic. So the electronic, let's say, would have a power, which would be a number. Maybe this could be power in watts. I mean, I don't really know the exact or let's just call it watts, because I don't think that watts stand for power. So let's just call it watts, and that's going to be a number, right? And we also can have a color again. That would be a string. We can have a size or shape. That could be also a string. Actually, let's make it a little bit more specific. We'll say this is a cylinder or a cube. Right, so maybe my microwave is a cube, is some sort of cube, some sort of parallelogram or something. We could call it like so. So cylinder, cube, maybe square, and the shape, the other shape could be flat. Let's say a TV is flat or something like so. Right, so we have a couple of different options here, and you already know that this vertical bar, it means and kind of or in TypeScript, right? So the shape can have any of these four values here, and we are not allowed to give any value that does not match these four values. Now we would have the, let's say, power on method, like so, and we would have the power off method, right? Power off method. So how are we going to use this power on? Well, and the power off. Let's think about it. Maybe we have a field here that is going to store the information whether a field or whether the electronic is on, right? And then once the power on is called, I will have the this.isOn equals to true. And if the power off is called, I'll say this.isOn is equal to false, like so, right? So it would be the case that the electronic here is going to have this field is on to indicate whether it's on or not, and I can change it via the modifiers or via the methods power on and power off. We will also add a constructor, and here let's use a bit more, let's say a bit more realistic example. We will receive a couple of args in my constructor, and these args are going to have the shape of electronic constructor args, like so. And I will define this type above. So we already did this in the past, and I will say that the type electronic constructor args is going to have three arguments, or three attributes. It's going to have vats, which is going to be a number. It's going to have a color, which is going to be a string, and it's going to have a shape, which is going to be this whole thing here, right? So now you may be wondering, well, one thing that I immediately see here, you say, oh, Lauro, I'm repeating the code here. What if I change one letter here, but I don't update the shape here, right? So let's see what happens if I try to say that this.shape is equal to args.shape, right? I have a problem because I have a typo here. If I add the E again, then the error goes away, right? So this is very error prone. Let's do a little bit of refactoring. So we'll cut this here, and we will say declare a new type, and we will say electronic shape. And then we say that this type is equal to this whole union here. And the electronic shape then is going to be passed to both of these two attributes, right? So the argument shape and the class attribute or the class property shape. So now we have that this.shape equals args.shape. We also have that this.vats is equal to args.vats. And that this.color is equal to args.color. Okay, like so. We still have the problem of the is on, so we will simply, whenever we create an instance of our class, we will say that the electronic is by default off, right? So is on is equal to false. Now let's create an instance of this. So I will say my const microwave, like so, is equal to a new electronic, and now I need to pass a couple of arguments. Now, as you can see, I'm using a different pattern here, right? So normally what you will see out there is you will see vats, which is going to be of type number. You will see color, which is going to be of type string, and then you will see shape, which is going to be of type electronic shape, like so. This is also okay if you want to do it like this, and you can simply delete these args here. However, this is order dependent. And this for me is a big downside. So if I didn't have number, string, and electronic shape, let's say I had string, string, and string, if I mess up the order, it's quite hard to identify that I really messed up the order, except by when I'm running my program and I'm seeing that the output is not the desired one. So order, when we have a bunch of parameters of the same type or a bunch of arguments of the same type, this can get quite tricky. That's why I prefer to use the pattern of an object, because passing an object and a single object is order independent. It doesn't matter the order I pass the keys of that object, it's going to work just the same. So I will change here to my pattern where I have args, and then an electronic constructor args, and then within this new electronic I need to pass an object, and this object is going to contain vats, which is going to say, let's say 800 vats, and then we have a color that's going to be gray, and then we have a shape that's going to be a cube, right? Like so. And Typescript is happy. right? So now I can say, I can see if my microwave is on, for example, microwave.isOn, something like this, right? However, okay, if I print this, that's going to print false because I'm initializing it to false. So let's just try here to set this to on. Microwave.isOn is equal to false, to true, sorry. And then it's going to print true. However, as you can see, there are already two methods here that are responsible for powering on and powering off my electronic. So if I want to, I can actually come to the isOn method and say private isOn, right? And then the moment that I mark the private or the isOn field as private, remember what we were discussing in the previous screen, that the field becomes accessible only within the class, right? So now I cannot access isOn outside of the context of this class. For example, if I wanted to check whether the device or whether the electronic is on, I could define a get is on or something like this, which is going to return this.isOn, right? I know that the maybe it could be a better name is electronic on, like so, because the isOn is already being used by my private variable. So maybe we could also change a little bit the syntax, or okay, I think I can do that. I just need to adjust this here. This._isOn_isOn, and then I can create the method isOn like so, right? So now I can actually access whether my device is on or not. However, if I want to turn it between on and off, I need to call my method power off, or my method in this case power on, right? And this should still print exactly the same in the console. Let's add a new line here. We'll say microwave.poweroff, and then we will print again whether microwave is on, and then it gives us false, right? So this is quite important. Of course, this example is a very simple example, but it is the case that we will often want to make a couple of fields private to the external world. And these fields would be the fields that are more related to implementation specifics, right? To the internal logic and internal calculations of a couple of methods or a couple of properties in our class. And because we don't want to make these functions or these fields directly available to the external world, then we mark them as private, and we create whatever methods here that we want to create so that we can adjust our private fields accordingly. So these methods here can be accessed from the external world, and then I can use them to change the value of our isOn variable and also to get the value of the isOn variable. You can see here that TypeScript is directly inferring the return type of these functions based on the return, based on the type of the _isOn. This should be void, and this should also be void. That's okay for us. If you want to be 100% complete here, you could type these functions like so, and this would be a boolean, right? So the isOn is a boolean. Good. Let's make a quick break here because the video is already getting a little bit long, and then in the next video we will go through the other types of modifiers. We will continue with this example because we spent a little bit of time in this video just conceiving the example. Let's stick to this example and discuss all the other modifiers in the next video. So if you're interested in receiving updates every time I post a new video on YouTube, then make sure to subscribe to the channel. There is a lot more to come in addition to the TypeScript series and to the microservices series. Make sure that you subscribe and you'll get a notification once new videos are out. And if you want me to cover a specific topic, then make sure to comment and add the topic in the comments of this video. If you see that there is any topic that also interests you, give it a thumbs up. I take into consideration the importance and the popularity of the topics when I decide which series I'm going to record next. Okay? So thank you for your time, and I'll see you in the next video. Bye-bye.